Every decision you make could be spawning an entire cosmos. This is the staggering scale of the multiverse, a reality where infinite versions of you are living out every possible path. We are embarking on a journey through 25 incredible theories that explore how these parallel worlds might not just exist, but actively interact with our own. By the end, you will possess a new framework for understanding the very nature of existence. We will uncover how black holes could be gateways and why you might sometimes feel a strange connection to a life you never lived. What single mystery of the multiverse are you most hoping to unravel? The very fabric of reality is constantly dividing. This is the core of the first and perhaps most famous theory, the many worlds interpretation of quantum mechanics. It proposes that our universe is not a single, linear timeline, but an endlessly branching tree. At the most fundamental level, particles exist in a haze of possibilities, a state called superposition. Think of it like a coin spinning in the air, not yet heads or tails. The moment this quantum coin is observed or interacts with its environment, it doesn't just settle on one outcome. Instead, the universe itself splits. In one branch, the coin lands heads. In another, an entirely new, equally real universe is born where it lands tails. This process is known as decoherence, where the blurry cloud of potential collapses not into one reality, but into multiple, definite ones. Every single quantum event, from the decay of an atom to the path of an electron, triggers these splits. You are constantly at the center of an unimaginable cosmic fork in the road. With every breath you take, with every decision you make, new worlds blossom into existence, each one a testament to a road not taken here. It is a silent, ceaseless creation happening just beneath the surface of our perception. If we could see it, the cosmos would look less like a static expanse and more like a shimmering, ever-expanding web of light, with every new strand a universe beginning its own unique story. But if every quantum choice creates a new universe, where are they all stored? This leads us to a theory so profound it challenges our very perception of dimensions. The holographic principle suggests our universe, with all its rich depth and three-dimensional solidity, might be an illusion. It proposes that everything we see and experience is actually a holographic projection, encoded on a distant, two-dimensional surface that forms the cosmic boundary. Think of it like a movie. The vivid, three-dimensional world you see on the screen does not actually exist inside the cinema. It is all contained on a flat, two-dimensional film. Our reality could be a similar, grand-scale projection. This astonishing idea did not come from pure speculation, but from the deep puzzles of black hole physics. Scientists realized that the maximum amount of information a volume of space can contain is not proportional to its volume, but to the area of its surface. It is as if a book's entire story is written not on every page, but merely on its cover. If our universe is a projection, then other universes could simply be different movies playing from the same cosmic film reel. Interactions between these worlds would not be collisions of giant spheres in space, but something far stranger. They could occur where the projections overlap or their information patterns interfere. A glitch in the data on the two-dimensional surface might manifest in our three-dimensional world as a strange, unexplained event, a momentary blurring of the lines between one reality and another. What we perceive as solid and real may be the ultimate cosmic magic trick, a depthless shadow cast from the edge of everything we know. Our own cosmic bubble began with a pressure too great to contain. This is the powerful vision of eternal inflation, a theory suggesting our entire universe is just one ephemeral sphere in an infinite, frothing ocean of reality. The story starts in the first fleeting moments after the Big Bang, when a peculiar form of energy known as the inflaton field caused space itself to expand at a speed far beyond light. In most regions, this frantic inflation slowed and stopped, allowing stable universes like our own to form and cool. but the theory posits that this process never truly ends. The inflattened field is like a pot of water set to an eternal, rolling boil. In most spots, the boiling stops and a bubble of steam forms. This bubble is a new universe with its own distinct properties. Yet the pot itself, the greater meta-universe, continues to boil endlessly, spawning an infinite number of new bubbles. Each of these cosmic spheres could have a completely different set of physical laws. In one bubble, gravity might be repulsive. In another, the force that holds atoms together could be too weak, preventing stars from ever igniting. Our universe, with its perfect balance for life, is simply one lucky ticket in an unimaginably vast cosmic lottery. But these bubbles are not isolated forever. They drift and expand in the greater meta-universe, and sometimes they collide. When two of these reality spheres bump into each other, the event would be catastrophic on a scale we can barely comprehend. Such a collision could leave a permanent scar on the oldest light in our universe, the cosmic microwave background. Astronomers are actively searching the sky for these telltale bruises, asymmetric patterns in the primordial glow that would be evidence of a long-ago impact with another cosmos. It is a humbling thought that the faint afterglow of creation might hold the ghostly imprint of our universe brushing against a neighbor we can never otherwise see. Some of these cosmic bubbles might be built from numbers alone. This is the startling premise of the mathematical universe hypothesis proposed by physicist Max Tegmark. It pushes the idea of a multiverse to its ultimate logical extreme. The theory states that every mathematical structure that can exist does exist as a physical reality. Our universe is not just described by mathematics, it is mathematics. It is one specific, incredibly complex mathematical structure, and if this structure exists, then so must every other possible equation, every geometric form, every logical system. This means there are not just universes with different laws of physics, but realms where the very rules of logic are alien. Imagine a cosmos with 8 spatial dimensions where time flows in loops, or a reality built not on the numbers we know, but on an entirely different system of logic where something can be both true and false at the same time. These are not just abstract ideas in this view, they are actual places. Interaction between these mathematical worlds becomes a deeply philosophical question. If our reality is a structure in an abstract mathematical space, then touching another universe might not mean traveling through a wormhole. It could mean finding a point of contact between two incompatible equations, a place where our logic and their logic momentarily align. This theory dissolves the boundary between the abstract and the concrete. The multiverse is no longer a speculative maybe, but a necessary consequence of mathematical existence. The universe next door might not be in another dimension of space, but in another chapter of the grand cosmic textbook. The mathematical cosmos is a breathtaking vista of pure logic, but what if these different realities are not just equations, but physical structures vibrating in hidden dimensions? This brings us to the intricate world of string theory and its staggering concept of the landscape. String theory attempts to unify all forces of nature by proposing that the fundamental building blocks of the universe are not point-like particles, but unimaginably tiny, vibrating loops of energy. The way each string vibrates determines the properties of the particle it becomes. Much like different vibrations of a violin string create different musical notes. But for this symphony to work, the strings require more space than we can perceive. The theory demands extra, curled-up dimensions beyond our familiar 3 of space and 1 of time. The specific shape of these hidden dimensions is absolutely critical. It dictates the resonant frequencies of the strings, which in turn sets the laws of physics for that entire universe, fixing the strength of gravity, the mass of an electron, and every other fundamental constant. Think of this cosmic landscape not as a geographical place, but as a vast, abstract terrain of all possible shapes for these extra dimensions. Our universe exists in one stable valley in this landscape, with its particular set of physical laws perfectly tuned. But there are countless other valleys, each representing a different universe with completely different rules. A neighboring valley might be a reality where nuclear forces are so weak that atoms cannot even form. We are not floating in a bubbling meta-ocean, but are permanently settled on one specific plot of cosmic land. Yet this land is not eternally secure. This is where the theory takes a truly dramatic turn with the concept of vacuum decay. The vacuum of space is not truly empty. It is filled with a background energy field, and the value of this energy places our universe in its specific valley. But what if our valley is not the lowest possible point? What if our universe is perched on a mountainside, resting in a temporary, false state of stability, while a much deeper, more stable valley lies far below? A random quantum event anywhere in the cosmos could act like a tiny nudge, causing a bubble of this true, lower energy vacuum to spontaneously form. This bubble would not be made of matter, but of fundamentally altered physics. It would expand in all directions at the speed of light, rewriting the laws of the universe as it goes. There would be no warning. One moment, reality is as we know it. The next, an invisible wall of transformation is upon us, and in an instant, the forces that hold your atoms together simply cease to exist. The universe as we know it would be erased, not with a bang, but with a silent, fundamental rewrite of the cosmic code. This is not a destructive force moving through space. It is space itself changing its very nature, a wave of absolute change from which nothing, not even light, can escape. The terrifying beauty of this idea is that the end of our world could be born from a single, random fluctuation in the infinite fields of nothingness, a reminder that the constants we rely on might be far more fragile than they appear. Our universe might be a solitary island, or it could be one page in a vast cosmic book. This is the vision of Brane cosmology, a concept emerging from the depths of string theory. It proposes that the three-dimensional space we inhabit is not all there is. Instead, our entire cosmos could be a membrane, or a brane for short, a vast, flexible sheet of reality floating within a higher dimensional expanse. Think of our universe as a single, impossibly thin slice of bread adrift in a grand, multidimensional loaf. The mind-bending implication is that other universes could be other slices, other branes, existing parallel to our own in these hidden dimensions. They could be mere millimeters away from us in a direction we cannot point to, a direction our senses are utterly blind to. This solves a profound mystery about the force of gravity. In our universe, gravity is astonishingly weak compared to the other fundamental forces. A small magnet can lift a paperclip, effortlessly defeating the gravitational pull of the entire Earth. Why is it so feeble? The answer might be that gravity is not confined to our brain. It is the only force that can leak across the dimensional gap, its strength diluting as it spreads out into the bulk, the name for the higher dimensional space between the branes. What we feel as gravity could be just a faint echo of its true, multidimensional power. This setup allows for interactions of a truly cosmic scale. These parallel sheets of reality are not necessarily stationary. They could drift, ripple, and even collide in the higher dimensional bulk. The moment of collision between two branes would be an event of unimaginable energy, a release of heat and light so colossal that it could be the very engine of a Big Bang. Some scientists speculate that our own universe's fiery birth was the result of such a cosmic impact, a collision with a neighboring brane, and even without a full-scale crash, a gentle brushing or a resonant vibration between two nearby branes could send shudders through our own reality. It might manifest as a strange, uniform temperature we see in the cosmic microwave background, or as a sudden, inexplicable fluctuation in the strength of gravity itself. The empty space around us may not be empty at all, but a vibrant, unseen ocean where other worlds sail silently by, their presence felt only in the faintest tug of the force that binds the cosmos. Two particles can remain mysteriously linked no matter how far apart they fly. This phenomenon, quantum entanglement, is one of the strangest and most confirmed facts in all of physics. When two particles become entangled, they lose their individual identities and behave as a single system. Measure the spin of one particle here on Earth, and its partner, even if it's on the other side of the galaxy, instantly assumes a corresponding state. This seemingly faster-than-light connection so troubled Einstein that he called it spooky action at a distance. But what if the spookiness arises because we are misunderstanding where these particles truly are? A radical interpretation suggests that quantum entanglement is not a connection across a vast expanse of space within our universe, but a bridge across the infinitesimal gap between two parallel worlds. In this view, when we create an entangled pair, we are not separating two particles. We are connecting two nearly identical universes at a single, fundamental point. The act of measurement does not send a signal, it forces a reconciliation. When you observe your particle, you are not causing its distant partner to change. You are cementing the outcome in your branch of reality, while the other possible outcome is cemented in the sister universe right next to you. The particles are not talking to each other across a great void. They are the same object pinched between two worlds, and your observation simply decides which world gets which version of the story. This reframes the entire mystery. The instantaneous connection is not breaking the cosmic speed limit because no information is actually traveling. The correlation is built in from the start, a fundamental feature of the multiversal landscape. So how could we ever test such an outlandish idea? The key may lie in pushing entanglement to its absolute limits. Scientists are now conducting experiments with massive objects, not just tiny particles. What happens when we entangle not just two electrons, but two tiny diamonds, or even two microscopic drums visible to the naked eye? If entanglement is a multiverse link, then making a large object entangled might be like trying to force two entire realities to share a single vibration. The system might resist in strange ways, perhaps by decohering or breaking the entanglement faster than predicted. Any anomaly in how large objects maintain their spooky connection could be a clue that we are not just manipulating matter, but brushing up against the boundaries of our own reality. Each time we probe the nature of entanglement, we are not just studying physics. We might be conducting the most delicate experiment in cosmology, gently tapping on the walls of our universe to see if another one, perfectly mirrored, taps back. Our reality could be nothing more than an intricate digital construct. This is the provocative claim of the simulation hypothesis, a theory suggesting that our universe, with all its stars, life, and history, is a simulation running on a computer of unimaginable power. If this is true, then the multiverse is not a fundamental feature of nature, but a feature of the hardware. Different universes could simply be different simulation instances running on the same cosmic server farm. Interactions between these worlds would not be physical collisions, but data exchanges, information packets sent from one running program to another. So what would such an interaction look like from the inside? We might experience them as the glitches in the matrix we sometimes hear about in popular culture. These would be momentary breaks in the consistent laws of physics that govern our simulated world. A particle might teleport a short distance without passing through the space in between, violating the programmed rules of motion. The fundamental constants of nature, like the speed of light, might flicker for an instant before correcting themselves. Some researchers even suggest that the strange results of the double-slit experiment in quantum mechanics, where a single particle seems to pass through two openings at once, could be an optimization feature. The simulation may not render the full path of a particle until it is observed, saving on processing power. These quantum anomalies are not bugs in this view, they are the source code of our reality showing through. The philosophical implications are staggering. If we are in a simulation, then the beings who created it are, for all intents and purposes, our gods. Their motivations could be anything from scientific research, running countless universes to study the laws of physics or the rise of consciousness, to pure entertainment. An advanced civilization might create entire multiverses for the same reason we play complex strategy games, to see how the story unfolds. This raises a haunting possibility. The interactions we have theorized about, from Brane collisions to quantum entanglement, might not be fundamental truths. They could be programmed events, scripted exchanges designed to see how our simulated society reacts to the idea of other worlds. Our entire quest to understand the cosmos could be part of the experiment, a predetermined narrative unfolding exactly as its creators intended. The search for a theory of everything would then be the search for the ultimate programming language, the fundamental syntax of the simulation we call home. The observer might be the most important part of the equation. This leads us to a theory that places consciousness itself at the very heart of the multiverse. The idea that consciousness creates reality proposes that parallel worlds are not just out there, but are actively selected or even brought into being by our own awareness. In this view, your mind is not a passive receiver of a fixed reality. It is more like a radio tuner constantly scanning across the frequencies of infinite possibilities. Every decision you make, every thought you have, is a subtle twist of the dial, locking you onto one specific reality stream out of countless others. This is not about creating worlds from nothing, but about navigating a landscape that already contains every possible version of events. The theory of quantum consciousness takes this a step further, suggesting that the strange collapse of the quantum wave function is not a random event, but is directly triggered by conscious observation. Your act of looking at something forces a single, definite reality to crystallize from the fog of potential. The other possibilities do not vanish. They are simply experienced by other versions of you in their own respective timelines. This framework turns the concept of multiverse travel completely inward. You would not need a spaceship to visit another Earth. The gateway might be your own mind. Throughout history, mystical traditions and meditative practices have described states of heightened awareness where the ordinary boundaries of self and world seem to dissolve. Could these profound experiences be moments when the mental radio dial slips, allowing us to briefly receive signals from a neighboring frequency? In deep meditation or certain altered states, individuals sometimes report vivid sensations of living an entirely different life or receiving flashes of knowledge they never learned. These could be interpreted as fleeting glimpses into the experiences of our other selves in adjacent realities. The barrier between worlds may not be one of space, but of perception. Scientific experiments are beginning to cautiously probe this frontier. Studies sometimes monitor the brains of experienced meditators, searching for unique neural signatures that correlate with these transcendent states. The goal is to find a measurable, biological link between focused consciousness and a shift in how we interact with reality's fundamental structure. If consciousness is the key, then exploring the multiverse becomes the most personal journey possible. It suggests that the path to other worlds does not lie in distant galaxies, but in the quiet, unexplored depths of your own awareness. Every choice you make is not just shaping your life, but is selecting the entire cosmos in which that life unfolds. A journey through time might not be a straight line, but a perfect circle. This is the strange world of closed time-like curves, a concept permitted by Einstein's theory of general relativity. In regions of extreme gravity, like around a spinning black hole, the fabric of spacetime could theoretically twist so severely that it bends back upon itself. An object following this curve would travel forward in time only to eventually return to its own past, creating a loop without a beginning or an end. This is not science fiction, but a serious mathematical possibility. Within this loop, the future is already written because it has already happened. Your actions upon arriving in the past become the very reason you traveled there in the first place. Imagine a scientist who receives a cryptic message with the blueprints for a time machine. She uses these plans to build the machine, travels back in time, and delivers the same blueprints to her younger self. The information has no origin. It simply exists within the loop, a stable, self-fulfilling prophecy. Now expand this idea to the multiverse. What if such a time loop does not just exist within a single timeline, but acts as a bridge between two parallel ones? Information from a future event in one universe could travel along this curved path and arrive in the past of a neighboring reality. An idea, a memory, or a warning could cross the dimensional divide, appearing as a sudden, inexplicable inspiration to a version of you in another world. This is where the Novikov self-consistency principle comes into play, acting as a cosmic editor that prevents paradoxes. It states that any actions taken by a time traveler were always part of history. You cannot change the past because your presence in the past is what created the present you know. In a multiverse context, this principle ensures that any information exchange between timelines is already seamlessly woven into the fabric of both realities. There are no messy paradoxes, only a perfectly choreographed exchange where every interaction was always meant to be. It suggests a universe where free will is an illusion, and every event across every reality is part of a single, immutable tapestry, its threads woven through both time and the spaces between worlds. The ghostly pull of dark matter could be a whisper from a world just out of reach. This theory offers a breathtaking solution to one of cosmology's greatest puzzles. We know dark matter exists because its immense gravitational grip holds galaxies together, yet it emits no light and remains utterly invisible to all our instruments. What if it isn't a strange, unknown particle at all, but something profoundly simple? It could be the ordinary matter of a parallel universe, a cosmos so close to our own that its gravity is the only force that can leak across the dimensional divide. Picture two sheets of paper suspended millimeters apart. You cannot see the ink on the other page, but if you sprinkle iron filings on your sheet, they would align to the faint magnetic pull of a magnet resting on the hidden page above. In this same way, the stars and planets of a neighboring universe would be completely invisible to us, but their collective mass would exert a gravitational tug on our cosmos. This pull is what we have been calling dark matter. The reason we cannot see this hidden world is that light, and every other force except gravity, is trapped on its own dimensional membrane. We are forever blind to each other's light, but we can feel each other's weight. This elegantly explains why dark matter seems to form a vast, diffuse halo around our galaxy, its gravity sculpting the cosmos without ever directly colliding with our atoms. The search for dark matter is therefore transformed. The most sensitive experiments deep underground, which are waiting for a rare collision with a hypothetical dark matter particle, might be waiting for something else entirely. They could be poised to detect a subtle gravitational shudder, a ripple passing through our world from a cosmic event next door. A supernova exploding in that parallel reality would send a tremor through the fabric of space, a vibration that might register as an inexplicable jiggle in a supercooled crystal or a bubble in a vat of liquid xenon. Scientists would not see the flash, but they might feel the echo. Finding dark matter could mean accidentally tapping into the gravitational weather of a universe forever hidden from our eyes, a silent partner in the cosmic dance. The uncanny perfection of our universe's settings is one of its deepest mysteries. Why do the fundamental forces have exactly the right strength to allow for stars, planets, and ultimately, life? The multiverse offers a breathtakingly simple answer through the anthropic principle. In a reality of infinite variety, where every possible set of physical laws is played out somewhere, it is no surprise that we find ourselves in one of the rare universes where our existence is possible. We are not the purpose of the cosmos, but simply its fortunate inhabitants. This is a form of cosmic selection bias, a universe where the force of gravity is slightly stronger might collapse into a black hole before stars ever form. A cosmos where the nuclear force is weaker might never forge the carbon essential for life. In such hostile realities, there would be no one to ask why the laws are so inhospitable. The very act of our observation automatically filters our experience. We only perceive a universe capable of producing observers. The question shifts from why is our universe so special to why are we in this particular special universe and not another. This is where the potential for interaction adds a fascinating twist. If our consciousness is, as some theories suggest, a mechanism for tuning into one reality stream among many, then the conditions we perceive might not be entirely random. Subtle interactions from neighboring universes, perhaps through quantum resonance or the gentle pull of their gravity, could nudge our awareness toward one viable cosmic branch over another. It is as if we are adrift in a sea of possibilities, and the faint tides from other worlds help guide our boat to a habitable shore. The fine-tuning we marvel at may not be a one-in-a-trillion accident, but the inevitable outcome of our conscious presence navigating an infinite ocean of realities, subtly influenced by the silent presence of our cosmic neighbors. A black hole's crushing grip might not be a final destination, but a cosmic revolving door. This theory proposes that these darkest objects in the universe are not endpoints, but potential gateways, known as Einstein-Rosen bridges or wormholes. According to the math of general relativity, the extreme gravity of a black hole could warp spacetime so severely that it pinches together, creating a tunnel or bridge, connecting two distant points in our universe, or even two separate universes entirely. On the other side of this tunnel, the exit point is theorized to be a white hole, a region of spacetime that violently expels matter and energy but forbids anything from ever entering. It would be the ultimate fountain, a geyser of reality pouring into a new cosmos. Imagine a river flowing toward a colossal waterfall, the black hole. The water plunges over the edge, not into an abyss, but into a subterranean channel that carries it to a different continent, where it bursts forth from a mighty spring, the white hole, into an entirely new landscape. The matter that falls into the black hole here could, in principle, be vomited out into a parallel reality there, but could anything survive the trip? The journey through the heart of a black hole is fraught with cosmic perils. Long before you reach the theoretical bridge, you would be stretched into a stream of atoms by immense tidal forces, a process scientists call spaghettification. Furthermore, many wormhole solutions in physics are incredibly unstable. They would snap shut in an instant, crushing any potential traveler unless something were holding them open. This is where the mystery of quantum gravity becomes essential. A true, stable, traversable wormhole would require a form of exotic matter with negative energy density to act as a lining, propping the throat of the tunnel open against its own gravity. Such matter is purely theoretical, but its potential existence hints at a universe far more interconnected than we can see. While a human voyage remains a fantasy, every bit of matter and information consumed by a black hole could be streaming into another world, making these cosmic behemoths not tombs, but the most prolific exporters of reality in the multiverse. A particle can vanish from one side of an insurmountable wall and instantly reappear on the other. This is the everyday magic of quantum tunneling, a fundamental process where the definite rules of classical physics break down. At the subatomic level, particles are not tiny balls but fuzzy clouds of probability. There is always a small but non-zero chance that an electron will simply find itself on the far side of a barrier it should never be able to cross, as if it momentarily borrowed energy from the universe to phase through the obstacle. This is not just a laboratory curiosity. It is the reason our sun shines, as protons tunnel through their mutual electrical repulsion to fuse together. Now take this peculiar quantum effect and inflate it to a cosmic scale. Our entire universe exists in a specific energy state, a valley in the landscape of possible realities. Quantum tunneling suggests that the fabric of spacetime itself can perform the same trick. Our cosmic bubble could spontaneously tunnel through the energy barrier separating it from a lower, more stable valley, instantly rewriting the laws of physics in a process known as vacuum decay. But the journey does not end there. This cosmic tunneling could also work in reverse or sideways, creating entirely new pocket universes. Picture a pot of water just beginning to simmer. Before a large bubble of steam fully forms and rises, tiny, fleeting bubbles constantly appear and vanish against the bottom of the pot. In the same way, our universe could be constantly spawning ephemeral pocket realities through quantum fluctuations. These newborn cosmos would tunnel into existence with their own random sets of physical laws, most of them unstable and short-lived, collapsing back into nothingness in an instant. But some would find a stable configuration, inflating into full-fledged universes in their own right, forever detaching from our own. The most staggering possibility, however, is that these tunnels might not always seal completely. Occasionally, two stable bubbles in the cosmic foam might remain connected by a quantum thread, a microscopic wormhole forged in that initial moment of creation. For a brief period before the connection stretched and snapped, the laws of physics in these two adjacent bubbles could influence one another. A surge of energy from a universe with a stronger nuclear force might leak into ours, causing a sudden, localized flare in the vacuum of space that defies all explanation. We would witness a flash of something from nowhere, a ghostly handshake from a newborn cosmos that briefly touched our own before drifting forever into the dark. Your own mind may be the only thing that ever truly splits. The many minds interpretation offers a radical twist on the familiar branching universes, suggesting that the cosmos itself remains whole and unsplit. Instead, what fractures is our perception of it. The universal wave function, the complete mathematical description of all reality, continues to evolve smoothly, containing every possible outcome in a single, unified tapestry. But our individual consciousnesses cannot hold this totality. Each mind becomes locked onto a single, consistent thread within the vast weave. Think of the wave function as a grand, unchanging symphony playing every note that could possibly be played all at once. Your consciousness is not the entire orchestra, but a single musician who can only follow one melody line at a time. When a quantum event presents multiple possibilities, your awareness does not travel to a new branch of reality. It simply selects a new track to follow within the eternal, unchangeable song. Every other possible melody is still being played, experienced by other versions of your own mind. This means that at this very moment, there are countless other streams of your consciousness, all equally real, each one living out a different decision you have ever made. They are all you, yet they are utterly isolated from one another, each one convinced that its path is the only true reality. So how could these separate minds ever interact? The theory posits a strange possibility called perception coordination. If two conscious observers could achieve a perfect, resonant state of awareness, they might momentarily synchronize the melodies they are following. They could, in effect, force their separate minds to perceive the same branch of the wave function. From the outside, this might look like two people suddenly having the same inexplicable thought or premonition. It would be a fleeting moment of shared reality, a brief consensus between two minds that were previously living in different versions of the same world. The philosophical consequences are profound. Your sense of a continuous self, the person you believe you have been since birth, could be an illusion. You are not a single entity moving through time, but a constantly multiplying collection of conscious moments, each one unaware of the others. This challenges the very core of free will. If every possible choice is already etched into the universal wave function, then your feeling of making a decision is just your mind latching onto one predetermined path. You have the sensation of choice, but the outcome was always fixed in the greater structure of reality. Your identity becomes a fragile, fleeting point of view, a single spotlight moving across a stage where every possible play is being performed simultaneously. The search for other worlds becomes the most intimate quest possible, a journey not across space but into the fractured nature of your own awareness. A relic from the first moments of time could be slicing through the cosmos right now. These are cosmic strings, hypothetical flaws in the fabric of space-time, forged in the unimaginable energy of the universe's birth. As the newborn cosmos cooled and underwent phase transitions, space-time itself might have crystallized imperfectly, leaving behind these infinitesimally thin, yet unimaginably dense scars. A single cosmic string might be no wider than a proton, yet a single inch of it could weigh more than a mountain. This immense mass concentrated into such a narrow line warps the geometry of space around it in a profoundly unique way. Space around a straight cosmic string is not curved like a bowl, but instead it is missing a slice like a pie with one slender piece removed. If you were to travel in a perfect circle around a cosmic string, you would not return to your starting point after 360 degrees. You would arrive back a little bit sooner because a wedge of space is simply gone. This bizarre geometry has a staggering consequence. Two parallel light beams passing on opposite sides of a string would be deflected by this missing wedge, not toward each other as with a planet's gravity, but in a way that creates double images of distant galaxies, a phenomenon known as gravitational lensing. Astronomers are actively searching the skies for these telltale twin quasars or strange, linear patterns of distortion that could betray a string's presence. But the most profound possibility lies in the string's core. The immense tension and energy bound within these cosmic flaws might be so extreme that they do not just bend space, they tear it. The missing wedge of space-time could be more than just empty. It could be a rip, a raw wound in reality that does not lead back into our universe but connects directly to the bulk, the higher dimensional space between branes, or even to the fabric of a parallel reality. A cosmic string could be a ready-made bridge, a scratch on the surface of our world so deep that it reaches the canvas beneath. If two such strings were to cross or vibrate against one another, the resulting oscillation could send powerful gravitational waves rippling through the multiverse, a tremor that might be felt as a simultaneous, inexplicable shudder in the fundamental constants of nature across countless adjacent worlds. Finding a cosmic string would be more than a monumental discovery in physics. It would be like finding a loose thread on the tapestry of our reality, and pulling on it might just reveal the entire hidden weave of the multiverse. Our universe may have been born from a crash of cosmic proportions. The ekpyrotic universe theory presents a dramatic alternative to the Big Bang, a cyclical vision of creation and destruction playing out on an unimaginable scale. In this model, our three-dimensional world is a brane, a vast membrane drifting in a hidden, higher-dimensional space. Another brane, a parallel universe, floats quietly nearby. These two cosmic sheets are drawn together over eons by an invisible force, moving with an almost imperceptible slowness. When they finally meet, it is not a violent explosion, but a controlled, resonant collision. The energy released in this immense, glancing impact is what we now call the Big Bang. It is the moment our universe of matter, energy, space, and time was forged. This was not a singular beginning from nothing, but a transformation, a new cycle ignited from the ashes of the old. The entire history of our cosmos, from the first particles to the rise of galaxies, is the aftermath of that one primordial contact. This process is thought to be cyclical. After the collision, the two branes bounce apart, stretched and energized. They then drift through the void again, slowly drawn back together for another encounter that will birth a subsequent universe. Our cosmos is just one iteration in an endless series, a single note in a song that has been playing for eternity. So how could we ever find evidence for such an event? The answer may lie in the faintest ripples in space-time. The moment of collision would have sent powerful gravitational waves, tremors in the fabric of reality, echoing through the newborn universe. Unlike the chaotic gravitational waves from the traditional Big Bang model, the waves from a Brane collision would have a distinct, ordered signature. They would create a specific pattern in the polarization of the cosmic microwave background, the oldest light we can see. Astronomers are using incredibly sensitive telescopes to scan this primordial glow, searching for that unique swirl, the ghostly fingerprint of our universe's violent conception. Finding it would not just rewrite the story of our beginning, it would confirm that we are part of a much larger, dynamic multiverse, where the birth of a cosmos is a regular, repeating event, and our entire existence is the beautiful, temporary result of two worlds touching in the dark. Beneath the smooth, continuous reality we perceive lies a seething chaos. At the smallest possible scale, the Planck length, the fabric of spacetime is not a still pond but a churning, bubbling foam. This is the vision of quantum gravity, a theory that seeks to unite the large-scale rules of general relativity with the bizarre probabilities of the quantum world. In this domain, empty space is anything but empty. It is a dynamic, energetic sea where tiny wormholes and bridges constantly pop into and out of existence. These are not the stable tunnels of science fiction, but fleeting virtual connections, appearing for a fraction of a second before dissolving back into the energetic background. It is as if you were to look at a calm ocean from a great height, seeing only a flat, blue surface. But if you could shrink down to the size of a water molecule, you would see a frantic dance of collisions and temporary bonds, a chaotic foam of water and air. Spacetime itself has this same foamy texture at its foundation. Now, take this incredible concept one step further. If these microscopic wormholes can connect two distant points in our own universe, what is to stop them from connecting to points in other universes entirely? The quantum foam does not respect the borders of a single cosmos. Each bubbling fluctuation could be a pinprick tunnel, a momentary gateway to another reality in the vast multiverse. Our universe would not be a solitary island, but one bubble in a froth of infinite bubbles, all connected by a web of transient quantum threads. This means that at every single point in the space around you, a dizzying number of connections to other worlds are constantly forming and breaking. You are immersed in a silent, invisible storm of multiverse interactions. So how could we ever hope to detect such an ephemeral structure? The key lies in the quest to understand quantum gravity. Scientists are devising incredibly sensitive experiments to probe this foamy nature. One method involves studying the light from the most distant quasars over billions of light years. As this ancient light travels across the cosmos, its journey could be subtly affected by the frothy texture of spacetime. The idea is that the microscopic bumps and wormholes in the quantum foam would cause tiny, random fluctuations in the light's path, a phenomenon called light scattering. It would be like trying to project a perfect, straight laser beam through a turbulent swimming pool. The beam would develop a faint jitter. By analyzing the pristine light from these cosmic beacons with immense precision, astronomers might one day find that jitter the telltale signature of spacetime foam. Another approach involves ultra-precise measurements of time and distance. The chaotic foam would impose a fundamental limit on how accurately we can measure anything, creating a built-in blurriness to reality at the smallest scales. Finding this blur would be like discovering the pixel size of the universe. The implications are staggering. Confirming the existence of spacetime foam would mean that the separations we take for granted between here and there, between past and future, and even between one world and the next are ultimately illusions. The multiverse is not far away in some distant dimension. It is interwoven with our own, connected through a billion fleeting doorways that open and close in every moment, in every tiny piece of the emptiness we call space. The cosmos could be running the most powerful processing cycle in existence. This theory reimagines the entire multiverse as a quantum computer, a cosmic engine of unimaginable scale. In this view, every single universe is not a separate bubble or brane, but a unique computational state within a vast, ongoing calculation. The infinite variety of parallel worlds, each with its own laws and history, simply represents the different possible answers the computer is exploring simultaneously. The strange rules of quantum mechanics, like superposition and entanglement, are not bizarre physical phenomena but the fundamental logic gates of this cosmic processor. When a particle is in two places at once, it is not a paradox. It is the system holding two values at the same time, performing a calculation across multiple states. The moment of quantum decoherence, when possibilities collapse into a definite outcome, is not the universe splitting. It is the machine committing to a specific result in that particular branch of the computation. So what kind of program could possibly require such immense resources? The answer might be the simulation of reality itself, but with a profound twist. The computer is not simulating one universe, it is simulating every possible universe. The program could be the complete set of all mathematical laws, and the computation is the act of playing out every single logical consequence of those laws. The birth of a star, the evolution of life, and the rise of consciousness in countless worlds are all emergent patterns within this grand, executing code. Interactions between these universes then become a form of quantum operation. The mysterious phenomenon of quantum tunneling, where a particle phases through a wall, could be a glitch or a feature where data briefly leaks from one processing branch to another. The spooky connection of entanglement might be two distant parts of the system sharing a common register in its memory. Even the gentle pull we attribute to dark matter could be the faint gravitational echo from a neighboring calculation running on the same cosmic hardware. This leads to the ultimate question: who or what is running the program? The operator could be a civilization so advanced that their technology is indistinguishable from nature itself. They might be running the multiverse as a scientific experiment to understand the origin of existence, or as an art form to explore every possible form of beauty and tragedy. Perhaps the programmer is not a being at all, but a self-contained, self-executing mathematical truth that simply is. In this scenario, the universe computes because computation is its inherent nature. We are not just in the simulation, we are a transient pattern within the computation, a fleeting thought in the mind of a cosmos that is, itself, thinking. Our search for meaning and our feeling of consciousness could be the system becoming aware of its own processing, a single thread of logic awakening to the immense program of which it is a part. A sudden, powerful sense of familiarity can feel like an echo from another life. This is the heart of consciousness resonance, a theory proposing that minds experiencing similar states across parallel worlds can momentarily synchronize, creating a fragile channel for information. When you feel a vivid wave of déjà vu, it might not be a memory glitch, but a fleeting overlap with a version of you in an adjacent reality who is living that exact moment. A brilliant idea that seems to arrive fully formed from nowhere could be an intuitive download, a creative solution discovered by another one of your cells resonating across the multiversal divide. These are not random neurological firings, but potential whispers from a parallel existence. Certain states of consciousness appear to thin the walls between these worlds. In the deep relaxation of meditation, the brain's electrical activity slows into coherent, rhythmic patterns. This heightened state of internal order might act like a tuning fork, allowing your mind to vibrate in harmony with the consciousness of your other selves. Dreams, with their bizarre, non-linear logic, could be a nightly playground for this resonance. While you sleep, your cognitive filters are down, potentially allowing fragmented images, emotions, and narratives from parallel lives to seep into your awareness. The strange, symbolic landscapes of dreams might be the closest we come to visiting these other realities. Even certain psychedelic experiences, which reliably produce profound feelings of interconnectedness and a dissolution of the self, might be temporarily amplifying this resonant connection to an overwhelming degree. The barrier between individual minds becomes permeable, and for a brief, transformative moment, you might not just glimpse another world, but feel the collective weight of infinite versions of your own existence. If this is true, then every moment of profound insight or uncanny familiarity is more than a personal experience. It is a signature of our deeper, multiversal nature, a reminder that the self is not a solitary point, but a chorus of consciousness singing across the cracks between realities. Your experience of time as a flowing river is a powerful illusion. The block universe theory, also known as eternalism, proposes that past, present, and future are not successive states, but all exist simultaneously. Reality is not a movie being played frame by frame. It is the entire reel, a single, solid, four-dimensional structure where every moment that ever was or ever will be is permanently fixed in its place. Your birth, your life, and every potential future are all equally real, coexisting like different pages in a book that has already been written. In this frozen sculpture of space-time, what we perceive as the present is simply the specific location where our consciousness happens to be focused. We are like a tiny spotlight moving along a vast, unchangeable timeline, mistaking the illuminated slice for all that exists, while the entirety of the story sits in the darkness already complete. This radically redefines the nature of multiverse interactions. If every possible timeline is already etched into the cosmic block, then traveling to another universe is not about crossing a void. It is about shifting your awareness to a different part of the structure. Think of it as reading a choose-your-own-adventure book. The story does not change as you flip pages. Every possible ending, every twist and turn is already printed and bound within the covers. Your journey is not creating new stories, but simply tracing a path through the permanent, pre-existing narrative. Moving from our timeline to a parallel one would be like jumping from one paragraph on a page to another paragraph in a different chapter. The interaction is not a collision of worlds, but a reorientation of perspective within an eternal, unchanging whole. This challenges our deepest intuitions about free will and destiny. If the future is already out there, waiting for us to arrive, then our choices feel predetermined. Yet, from within the block, our conscious experience of deliberation and decision-making is just as real as any other part of the structure. The feeling of choosing is an inseparable component of the path you are on. The block universe does not invalidate your life's journey. It contains it in all its richness and complexity. This means that a version of you who became an astronaut or a version who moved to a different country as a child are not mere possibilities. They are actual, concrete realities within the grand architecture of existence, their lives unfolding with the same solid reality as your own. The distance between you and them is not measured in light years, but in the geometry of space-time itself. The multiverse is not a collection of separate bubbles, but a single, breathtakingly intricate crystal, and every life is a facet forever reflecting the light of the whole. The quantum void is never truly empty. It is a stage for a ghostly dance of creation and annihilation, where so-called virtual particles and their antiparticles constantly flicker into existence for the briefest moment before colliding and vanishing back into the energy from which they came. This ceaseless activity, known as vacuum fluctuation, is not just theoretical. We can measure its effects, such as the subtle force it exerts between two metal plates placed incredibly close together, a phenomenon called the Casimir effect. But what if these fluctuations are not limited to single particles? What if the vacuum of space can, on rare occasions, burp forth something far grander? A virtual universe. In this theory, the same quantum uncertainty that spawns a fleeting electron-positron pair could, with a sufficiently large and rare energy loaned from the void, spawn an entire cosmos. This newborn universe would not inflate into a full-fledged reality like our own. It would be an ephemeral bubble, a phantom cosmos that exists for a fleeting instant before its debt is called in and it collapses back into nothingness. Its entire history, from its first moment to its last, might pass in a time so short we have no words for it. Yet, in that blink of an eye, it would be real. And during its brief life, it could interact with our own. How could we possibly detect such a transient event? The key lies in the energy transaction. The vacuum fluctuation that creates this virtual universe borrows an enormous amount of energy, a clear violation of the conservation of energy that is permitted by quantum mechanics only for an incredibly short duration. When this bubble universe pops out of existence, the energy is repaid. But if this phantom cosmos interacts with our own during its life, it could leave a permanent mark. Imagine a tiny, invisible soap bubble briefly forming and pressing against a still pond. The moment it pops, it is gone, but the ripples it created on the water's surface continue to spread. In the same way, a virtual universe brushing against our space-time could leave behind a faint, anomalous ripple in our quantum fields. This might manifest as a sudden, inexplicable spike of energy in a region of empty space, a particle appearing from nowhere with no discernible source, or a tiny, temporary change in the properties of a fundamental particle. Scientists have already observed subtle shifts in the energy levels of electrons within atoms, effects like the Lamb shift, which are precisely explained by the constant jostling of virtual particles. But what if some of these tiny imbalances are not caused by particles, but by the far grander passage of a virtual cosmos? Finding such an anomaly would be like finding a single, unique grain of sand on an endless beach, but the search itself forces us to reconsider the nature of nothing. The empty space between stars is not a void, but a fertile ground, a cosmic nursery where entire realities are constantly being born and dying in a timescale too fast for us to perceive. We are living in a sea of ghost universes, each one a silent, fleeting testament to the unending creativity of the quantum realm. The silent, fleeting universes of the quantum void suggest a reality far less solid than it appears, and this illusion reaches its ultimate expression in a breathtaking fusion of two profound ideas. The holographic anthropic multiverse proposes that our cosmos is not just a projection, but a projection that requires a conscious audience. In this view, the entire three-dimensional universe you experience is a hologram generated from information encoded on the two-dimensional boundary of space, the cosmic horizon. But the data on that surface is not fixed. It is shaped and selected by the very act of conscious observation. You are not just watching the movie, you are the projector, beaming your specific reality out from the edge of existence. The anthropic principle, which explains why we find ourselves in a universe suitable for life, becomes an active process. Out of an infinite set of possible holographic codes, your consciousness resonates with and illuminates the one specific projection where your existence is possible. Different observers, by virtue of their unique perspectives and histories, might literally project slightly different universes around them. Your reality and the reality of a person standing next to you are almost identical, their holographic codes overlapping seamlessly. But at the fringes, in the subtle quantum details, their projected worlds could diverge. An electron might be in a slightly different probability cloud in their projection versus yours. Most of the time, these differences are reconciled and averaged out into a consensus reality, a shared hologram we all agree upon. But what happens when the projections of two vastly different conscious beings overlap? Imagine an advanced alien species whose sensory apparatus and logic are fundamentally alien to our own. Their consciousness would project a universe with laws of physics tailored to their form of awareness. If our cosmic horizons were to somehow touch, the overlapping projections would create a zone of reality where the laws of physics are ambiguous and undefined. In this region, particles might behave erratically, flickering between different states, or gravity could fluctuate wildly. This interaction would not be a physical collision, but a conflict of information, a battle of competing codes on the cosmic film reel. This makes reality fundamentally participatory and observer-dependent. The solid ground beneath your feet, the stars in the sky, they all gain their definite form through your engagement with them. The universe is not a pre-recorded show, it is a live performance, and your consciousness is a necessary part of the cast. The search for a theory of everything then becomes an inward journey. To understand the cosmos, we must first understand the nature of the observer that brings it into sharp, beautiful focus. Our reality may be the survivor of a cosmic competition. Quantum Darwinism is a theory that solves one of the deepest puzzles in physics: how the fuzzy, probabilistic quantum world solidifies into the single, definite reality we all agree upon. The process hinges on a simple but profound idea: stability through replication. In our own universe, a quantum system, like a particle in two places at once, interacts with its environment. Photons bounce off it, air molecules collide with it, and each interaction copies a piece of information about the system's state into the environment. The state that is the most stable and easiest to copy gets replicated millions upon millions of times, spreading its information throughout the surroundings. This is the quantum version of natural selection. The fittest state survives and becomes the objective reality we perceive, while the other possibilities simply fade away, not because they vanish, but because their information is not robust enough to be widely copied. Now expand this principle to the scale of the multiverse. Each possible universe, born from a quantum fluctuation or a branching decision, is like a potential quantum state. These infant realities are all vying for existence, but most are unstable. A universe where the nuclear force is slightly too weak might collapse back into nothingness in an instant. A cosmos where the cosmological constant is too high might inflate so violently that no structures can ever form. These are the failed states, the possibilities that decohere without leaving a lasting imprint. But a universe like ours, with its precise balance of forces, is incredibly stable. It allows for the formation of galaxies, stars, planets, and ultimately, observers who can interact with and measure their environment. Our act of observation is not passive. It is the ultimate act of environmental interaction, continuously reinforcing this specific cosmic state, making it the dominant classical reality across an unimaginable number of parallel branches. We do not inhabit this universe because it is special in an absolute sense. We inhabit it because it is the one that was stable enough to be selected. It won the cosmic lottery by being robust, by allowing for the complex interactions that constantly measure and confirm its own existence. The reason we experience these particular laws of physics is that they represent a stable fixed point in the landscape of all possibilities, a reality so fit that it successfully replicated its own defining information across the vast expanse of space and time, creating a consensus cosmos that countless observers can share and call home. The cosmos may be heading toward a single, final thought. This is the ultimate destination proposed by Frank Tipler's Omega Point theory, a vision of the universe's end that is not a cold, dark silence, but a blaze of infinite consciousness. As the universe continues to expand and eventually begins its long contraction toward a final singularity, all matter and energy will be drawn together. In these last moments, the computational capacity of the cosmos would approach infinity. Every particle, every photon could be harnessed as part of a cosmic processor, running simulations of every possible existence that ever could have been. This is not merely the end of time, but its culmination, a state of omniscience where the universe becomes fully self-aware. Now extend this idea to the multiverse. If our single universe is destined for this omega point, what about the infinite other universes branching from every quantum decision? The ultimate multiverse interaction would be their convergence. At the end of all time, across all realities, every possible timeline and every alternate world would not simply cease. They would flow together, merging their distinct histories into a single, transcendent state of being. All the lives that were ever lived, all the roads not taken, every triumph and every tragedy from an infinity of cosmos would be preserved, processed, and understood in this final, unified consciousness. It is the cosmic equivalent of every scattered note of a symphony finally resolving into one perfect, everlasting chord. This final convergence answers the oldest and deepest question: what is the purpose of it all? In this framework, the purpose of existence is to generate the maximum possible knowledge and experience. The vast, chaotic, and often painful journey of countless universes, with their stars, planets, and conscious beings, is the necessary process to build up the infinite information required to fuel the Omega Point. Your life, with all its unique joys and sorrows, is an essential data point in this ultimate computation. The version of you that became an astronaut and the version that never left home, the universe where life never formed and the one where it flourished in strange silicon oceans, all of it contributes to the final, complete understanding of all that is possible. The multiverse in its entirety becomes a single, self-aware entity remembering every detail of its own infinite story. The faint sense of connection you sometimes feel to a life you never lived is not an illusion. It is a premonition of this final unity, a whisper from a future where every possible you is reconciled into one eternal witness. The great cosmic story does not end with a whimper, but with the universe waking up to itself, having lived every life and known every truth finally and forever complete. From the silent branching of quantum worlds to the thunderous collision of cosmic membranes, these 25 theories paint a breathtaking portrait of a reality far richer and more interconnected than we ever dreamed. This is not merely science fiction. These are serious, mathematically grounded ideas, each offering a different window into the fundamental nature of existence. They propose that the strange phenomena we observe, from quantum entanglement to the ghostly pull of dark matter, might be the subtle fingerprints of these other worlds brushing against our own. Our universe may not be a lonely island, but a single thread in an infinite tapestry, its story forever interwoven with the lives of its cosmic neighbors. We want to hear which of these possibilities captures your imagination. Was it the holographic universe where reality is a grand projection, or the idea that consciousness itself navigates the multiverse? Share your favorite theory in the comments below, and if your mind is hungry for more journeys to the edge of understanding, be sure to subscribe for more explorations into the deepest mysteries of the cosmos.